Okay, let's look at the solution of this paper. For question number 1, make P the subject of the formula PQ minus 1 times equals to P bracket M plus 1. You need to make P as subject, so PQ minus 1 equals to P bracket M plus 1, and you need to multiply P inside the bracket. So PQ minus 1 equal to PM plus P. And also you can see that you need to move all these terms to another side with PQ minus PM minus P equals 1. So take out the common factor P here, so that's P bracket Q minus M minus 1 equals to 1. And finally move this big term to another side. That's 1 over Q minus M minus 1. So that's finished. This is the solution of question number 1. Go to question number 2. Simplify these expressions and give the answer with positive indexes. So m to the power 6 times m to the power negative 9 over m to the power negative 2 and n to the power bracket negative 3. What we can do, first of all, for the numerator, you'll find that it can be simplified. This becomes m to the power negative 3. Why? Because when you are doing the multiplication with the same base, you need to add the index up. Okay? 6 plus negative 9, that's negative 3. And the base does not change. In the denominator, you can multiply negative 3 inside the bracket. So this becomes m to the power positive 6 and then n to the power negative 3. Next one, how do we write down the answer? That is, when you are doing division, you are subtracting the number of the index and keep the base no change. So that's m to the power negative 9 and denominator n to the power negative 3. So you need to change back the index be positive. That's become m to the power 9 in the denominator and then n to the power 3 in the numerator. Okay, so let's finish this question. Go to question number 3. Okay, factorize these two parts. When you look at there's a symbol alpha and beta, it does not mean that it always related to sum of root and product of roots. Okay, it's just a symbol. Okay, so you need to look at the question carefully. Alpha square minus 4 beta square. Now I repeat, this is not sum of root and product of root in this question. Okay, there's no any equation here. Also, we call this as alpha, not A. This is beta, not B. Okay, it can be directly become as alpha plus 2 beta times alpha minus 2 beta. There's a very standard format of the difference of 2 square. So part B, you need to simplify alpha square minus alpha minus 4 beta square plus 2 beta. And you can group these two up. Alpha square minus 4 beta square. You write here like this. And then minus alpha plus 2 beta right in this way. So when you look at these first two terms, you can see that it can be factorized alpha plus 2 beta times alpha minus 2 beta. For the last two terms, you take out the negative side, that's become alpha minus 2 beta. Okay, so you can see there's a common factor now. Then what you need to do is you write down one time on left hand side, and what's left just remove. Okay, block it like this. The first square bracket it left alpha plus 2 beta here, and the second term it just left 1 here. There's a hidden 1 here. Okay, don't miss this. Okay, so the final answer will be alpha minus 2 beta times alpha plus 2 beta minus 1. Okay, that is the solution of question number 3. So go to question number 4. there's a question about the compound interest. Sum of 88,000 is deposited in the rate 6% per annum. That means every year. For 7 years, compound quarterly. That means 3 months, every 3 months. So you can look at here. 1 year, it will count 4 times. Okay, and 7 years, it will count 28 times. So the effective period will be 28. Also, for 1 year, it counts 6%. So every 3 months will become 6% divided by 4. Therefore, the effective rate is 6% over 4. That is 1.5%. Okay? Therefore, the interest will be the amount 88,000 times 1 plus 1.5%, the effective rate, to the power 28. That is the amount. You need to minus 88,000. Okay? Minus the principal. Then you use the calculator to plug in. 88,000 multiply with 1 plus 1.5 divided by 100 to the power 28. That is the amount. Minus 88,000. That is this one. Okay? 45516. Correct to the nearest. Dollar. Okay, the number seems quite big. Okay, you may check it again. 88,000 times 1 plus 1.5 divided by 100 for 7 years. So to the power 28, and then minus 88,000. Yes, okay, 45,000 something. So that's the end of question number 4. And then let's move to question number 5. Okay, that's the question about the area and volume. The radius of a solid hemisphere and the base radius of the solid right circular cylinder are equal. So you have the hemisphere, base radius r, and cylinder, okay, toilet paper cone, okay, base radius r again. The height of the circular cylinder is equal to the diameter, okay, base diameter. That means the height 2r. Part A, find the ratio of the total surface area of the hemisphere to that of the circular cylinder, total. So this one, total surface area will be 1/2 times 4 pi r square, because there's a total surface area of the sphere divided by 2. Hemi means half. But don't forget, you need to add one more pi r square, because you need to include the base. And here, the total surface area is 2 pi r times the height 2r. This is the curved surface area. But don't forget, you have 2 parts, upper part and the bottom part, plus 2 area of circle, 2 pi r square. So, you will write that in this way. The ratio equals to 1/2 times 4 pi r square plus pi r square. That's the total surface area of the hemisphere. And in the denominator, that is 2 pi r times 2r plus 2 pi r square. That is the total surface area of the cylinder. So simplify this. In the numerator, 4/2, 2. 2 plus 1, so that's totally 3 pi r square. In the denominator, 2 times 2, 4. 4 plus 2, 6. That is 6 pi r square. Luckily, you will find that pi pi and r squared can be cancelled. That is 3 over 6. And you cancel 3 over 6 again, that's 1 over 2. That's the corresponding ratio, 1 over 2, or you answer 1 to 2. Also acceptable. Okay? And B, if the height of the cylinder is 6 cm, that means it is 6. Then you know that R is 3. So that's quite trivial. You can find the volume of the hemisphere. So part B, the volume would be 1 over 2 times 4 over 3 times pi times 3 to the power 3. Okay? And don't forget the unit cm cube. So use your calculator. In this time you need to plug in pi also, because the question did not ask you to leave the answer in terms of pi. So 1 over 2 times 4 over 3 times pi times 3 to the power 3, 56.5. 3 significant figures. 3 significant figures. That's it. Let's finish question number 5. And then go to question number 6. Let gx be x squared plus 4x plus b, where b is a constant. Suppose gx is divisible by x plus a. Find the remainder when gx is divided by x minus a. And b, solve this one. G bracket x minus 1 equals 0. And we know that when gx is divided by a linear polynomial, the remainder would be g to the negative 8. That means x becomes negative 8 and substitute in. And the remainder is 0. So you have this relationship. So part A, g negative 8 equal to 0. You can do nothing about this one. You can only work with this one by substitute x equals to negative x in this side. So negative 8 bracket square plus 4 times negative 8 plus b equal to 0. Okay? So that would be 64 minus 32 plus b equal to 0, and b equals to negative 32. Okay? So you can find the remainder when gx is divided by x minus 8. That is, find g positive 8. The remainder is g8. What does that mean by g positive 8? That is, x become positive 8, and substitute in here. B is negative 32. So you get the 64. That means when gx is divided by x minus 8, the remainder is 64. Okay? And B, you need to solve this one. Now what does that mean, gx minus 1? That means all x, replace x by x minus 1. That means in here, not x anymore. It should be bracket x minus 1. So you will have the equation x minus 1 all square plus 4 bracket x minus 1 and then minus 32 equal to 0. That would be the equation you have. Okay? Now, remove the bracket and solve it. X squared minus 2x plus 1 plus 4x minus 4 minus 32 equal to 0. And you will have x squared plus 2x minus 35 equal to 0. So, x plus 7, x minus 5 equal to 0 by using cross method. X is negative 7 or x is positive 5. Then let's finish this question. That is the answer of question number 6. Go to question number 7. The diameter of the circle is 20 cm. The circle divided into a major segment. What does that mean, segment? Let's draw the circle. The diameter is 20 and the circle is divided into a major segment and minor segment by a chord of 12 cm, something like this. Okay, I'll write 12 cm. And the segment means the area, the region covered by the arc to the chord. The smaller part we call it as minor. The bigger part we call it as major. So I want the minor part. This one, whole area, I want to find. I want to find this one. So how do we start? If you have no idea about the area of circle or angle of circle, one of the common way is mark the center and join it to the chord like this. Join the two ends of the chord. So you will get both radius are 10. And again, if you draw a line from center to perpendicular to the chord will cut into two parts, two equal parts. That's 6 and 6. So you can see that in this right angle triangle, I can extract this triangle here like this. 10, 10, 6, 6. You can find these two angles. You can find these two angles. They are the same. Because left-right triangles are congruent. Very easy to check. So you can find these two angles. You can use sine. Sine, mine is theta. Sine theta, that is 6 over 10. Okay, sine theta, that's 6 over 10. And hence, you can find theta, that is shift sine 6 over 10. 36.8 something, I write it down, 36.869896765 degrees. So, if I want to find the blue area here, I just need to use the big zeta. The big zeta. Okay, that's 2 theta, 10, 10, minus the area of triangle, right? Then I can find the area of this. So the required area will equal to pi multiplied to r squared multiplied to this angle times 2, that is 73 point something, divided by 360 degrees. That is the area of the big zeta minus the area of the triangle. How to find the area of this triangle? As you can see, we find theta, we have 10, we have 6. By using Pythagoras theorem, we know that the height of this triangle is 8. So, actually the area of this triangle is 12 here, and the height is 8. 12 times 8 over 2. Okay? And hence you can find the answer, pi times 10 squared times this answer, this angle, divided by 360 minus 12 times 8 divided by 2. The answer 16.3 something. 16.4 cm squared. Oh sorry, correct to the nearest cm, so it should be 16 cm squared. Correct to the nearest cm. The key point is you need to understand the meaning of the word segment. That is the area covered by the arc to the chord. And you can see that if we join the center to the perpendicular to the chord, it will cut into two equal parts, 10, 6, and that is 8. Okay? So you can find the area of this triangle very easily. So that's the end of question number 7. And go to question number 8. Let Z be the very difficult expressions. K is real, and suppose the real part and the imaginary part are equal. You need to find the real part of Z, and then express this one in form of A plus BI. So let's investigate this one. Z equals to K I to the power 14 plus 13I 21 minus I to the power 22 plus 7i to the power 23 minus 2ki to the power 25. So I to the power 14 actually equals to I squared. Why? Because I to the power 12 is 1. Okay? So I to the power 14 equals to I squared. Alright? Similarly, I to the power 21, that is equal to I, because I to the power 20 is equal to 1. When the index is the multiple of 4, I to the power 4k is always 1. Okay? So here, I to the power 22 is I to the power 2, plus 7i to the power 3, and then 2k minus 2k, and then I. Again, I to the power 24 is 1 again. So you can simplify this. This is negative k plus 13i minus 1 minus 7i and then minus 2ki. Hence, you can group the real part. Negative k minus 1, the real part, plus 13i minus 7, that's 6i, 6 minus 2ki, as the real part equal to the imaginary part. So negative k minus 1 equals to 6 minus 2k, and hence k equals to 7. K equals to 7. So z equals to negative 7 minus 1, that should be negative 8, and then 6 minus 2 times 7, again negative 8i. Alright, so let's finish part A. Part B, we know that z is this one. Then how do we simplify this one? Okay, how do we simplify this one? Okay, we substitute in here, so that should be z over 1 minus z, that should be negative 8 minus 8i, and then 1 minus negative 8 minus 8i, so that is negative 8 minus 8i over 9 plus 8i. 9 plus 8i. Okay, and hence we move to here. Okay, I need more spaces to write it down. That is negative 8 minus 8i multiply to 8 minus 8i, because in the denominator I have 8 plus 8i multiply to 8 minus 8i. So you will have the denominator 9 squared plus x squared, because that should be 9 squared minus 8i squared, so it becomes a positive. Okay, and in the numerator I need to multiply something here. Negative 8 multiplied to negative positive 9, negative 72, and then negative 8 times negative 8i plus 64i. Similarly, minus 72 and then minus 64. Alright, so in the denominator, that is 9 squared plus x squared, 145. In the numerator, negative 72 minus 64, negative 136. And how about I? That is positive 64 minus 72, negative 8i. So therefore, the final expression will be negative 136 over 145 minus 8 over 145 times I. So you may use the calculator to check whether it has any common factor. No, so that is the final answer. Let's finish question number 8. And go to question number 9. Let G be the quadratic graph of y equals x squared minus 2x minus 8. And L be a straight line, okay? Y equals 16. G cut the x-axis at A and B, and arrow cut the graph G at C and D. So if you want to know what is the position of A and B, you can substitute y equal to 0. Okay? So when we substitute y equal to 0 in this graph, then you will have x squared minus 2x minus 8 equal to 0. So you will have these two answers, x equals positive 4 or x equals negative 2. So one of them will be negative. Let's say A. A is negative 2, 0. B is 4, 0. Okay? Or you can change it. You can call this as A. It doesn't matter. And next one, it also cut the straight line y equals 16. So when you substitute y equals 16 in this quadratic graph, okay, then you will get x squared minus 2x minus 8 equals 16. So just solve it. You will have another answer. You will get x equals to positive 6 or x equals negative 4. And what does that mean? That means if you draw the quadratic graph, that's G, and you draw a horizontal line y equals 16, then it will cut another 2 points again, right? Called C and D. C would be C negative 4, 16. Because you solve the x coordinate is negative 4, and the y coordinate, of course, is same as this horizontal line, 16. And other one will be D, that is positive 6, 16. Now what we need to find is the area of this quadrilateral ABCD. In here, AC, this curve is not a straight line. You need to join this like this, okay? This one. Okay? You need to find the area of this one. This red one. This is a trapezium because these two straight lines are parallel. So the area of this trapezium actually will be the upper length, that is 6 minus negative 4. That's 10 actually. And the lower part, the length is 4 minus negative 2. That's 6 actually. And the height of this trapezium, that's 16. So upper base plus lower base times 16 over 2, then you will get the answer 128. So that's the end of this question, and that's the end of this paper. Thank you.